what we will be talking about today is a concept called force. Now, we're not going to cover everything there is to know about force. This is just a basic introduction to the idea. Now, like with many words we use in physics, you may hear it in many different contexts in different areas. But when we use our word force in physics, we need it to mean one very specific thing, which is what we'll define. Now, you may have used the word force before in many situations in your own life. You may have said, oh, she's forcing me to eat the spinach, or I forced the door open so I could get in, or even you may have heard people use force to describe the way they spoke or something that they did. And those are all perfectly valid ways to use force. However, when we talk about force in physics, we need to have a definition for what we're talking about. When we are talking about force, we are talking about a measurable amount of energy that we put forth in an object, such as our little yellow ball here, and measurable amount of energy that we put forth in an object, and not just how much energy, but this energy has a direction that it is moving. In mathematics, we will represent this measurable amount of energy that has a direction with something called a vector, which we will get more into later. Now, when we are talking about force, we are talking about how much force it takes for something that weighs a certain amount to accelerate, in other words, to get faster and faster, and at a certain measurable amount of time. All right? So, in other words, we use a unit of measure called newtons, and a newton is a unit that we use to measure force. And a newton talks about if we have an object like, say, our cute little yellow ball, and we have 1 newton, so 1 newton would move a kilogram of mass, it would cause it to accelerate 1 meter every second, so it goes 1 meter per second faster each second that passes. So after 1 second, it would be going 1 meter per second. After 2 seconds, it would be going 2 meters per second, getting faster and faster. After 3 minutes, it would be moving 3 meters per second. Now, when you are doing your time measurement project, I want you to think about some of the forces that could be causing things to happen in your experiment. You don't need to do a calculation, but I do want you to think about what sort of forces are acting on our object. And the first thing that I'm going to introduce to you, 2 of Newton's laws. Newton's first 2 laws of forces, to help you understand a little bit what a force is when we talk about it in physics class. So first of all, Newton's first law is what we just talked about. A force causes an object with mass. Now, I don't think you guys can really think of anything of an object that doesn't have mass, right? So we're talking an object that has mass. When it's on Earth, it weighs something. My sunglasses have mass. This pencil has some mass. You have a mass. An object with mass to accelerate. That means go faster and faster. So when we put a force on our cute little red ball here, it's going to cause it to accelerate. It goes faster and faster and faster and faster for every second that passes. And then I want to start to address Newton's second law. Newton's second law tells us that object at rest stays at rest. If you take your pencil, you put it down, and there's no other forces acting on it, it's going to stay at rest. Unless some force acts on it. We'll talk a little bit more about what those forces could be later. Newton's law also tells us an object at motion stays at motion, right? Well, let's think about that. Let's think about how this works. You were sitting on the grass and you put some force onto our little yellow cute 1 kilogram ball. And you pushed it, what would happen? Well, it would go and it would go, and maybe it would start going faster if you kept pushing it and giving it force, but eventually it would slow down if you stopped pushing it. Why is that? And you have to consider that on Earth there's all sorts of things that happen, all sorts of things around that are also going to have forces on them that have to do with that ball. For instance, got lots of grass on the ground here, right? That grass is actually putting a force against the force you put on it. It's called friction. It's going to slow it down. So, even if you keep pushing force on it, it may not keep accelerating, and once you take the force away, though it's at motion, it's not going to stay at motion, but that's because there's other forces acting on it, such as friction. There also could be, and I know clouds don't really make wind, but I'm going to use this to represent it, be wind. There could be wind blowing that ball that causes it, that motion that you gave it in the first place, to stop moving. So, these are just some basics to help you understand what we are talking about when we're talking about force. And I want you to try to tie these ideas of forces and think about what are some of the forces that might occur to your cute little yellow ball, or that might occur to your time measurement tool that you will be creating in your project. And try to tie these ideas of force and use this vocabulary word force to describe what is happening.